Yeah, we've gone live. All right, everybody who's going live, I'm hoping that you can hear me and that it's not too loud. We've not quite started the talks yet, but I'm really hoping that some of you in the chat will give me a little bit of feedback. Can you hear us? Is it horrible? Hopefully everything's working. Well, there's a delay, so let me just wait. So hopefully people can hear us. Okay, here we go. I'm going to get it started anyway. Oh, great. Audio is good. Fantastic. I just got the first one through. So if you're just hearing this, there's going to be a little bit of a delay. All right, I'm gonna ding my glass real loud. So hide your ears. Hello, everybody. It is time to say some words. So come and sit down in the chairs. There are extra stools if you run out, just there on the left. So yeah, please come and sit down, make yourself comfortable. We have a bunch, we have a number of speakers for you tonight, but we're also streaming this live. Not your lovely faces, just pointed this way, just so you know. And this is the first time we've done it, and most of this AV equipment I'd only seen a couple of days ago, so please excuse me if it's not perfect, but I'm sure it's going to be wicked anyway. Plus it's free, so you can't complain. All right. Let's take a little seat, and I'll kick it off. All right. There's like 4 lovely seats at the front. You don't have to sit here, but you know, I'm just telling you that they exist. Yeah, fine, right. We're all being standoffish. That's fine. That's okay. All right. Well, hello. I'm going to just get going. My name is Helen Leigh, and I'm the organizer of tonight. So everything you can blame and praise me equally. Yeah, if any of the chairs are wonky, sorry. I had to put them all together very quickly. I didn't have enough time to put together any slides, so you're not hearing a proper talk from me today, but I am going to introduce to you the idea of the event. I'll also talk a little bit about my work, not with slides, more with the random handful of my old projects that I picked up as I was leaving the house this morning. Where shall I start? I've been too busy running around. Here we go. So basically, should I start with the sound hacker's point, or shall I start with me? Let me start with an introduction to myself so you know where I'm coming from, okay? I moved to Portland a couple of years ago, and before that I was active in the Berlin hacker community, and before that, you know, pre-Brexit, I was active in the London hacker community, and both London and Berlin have got, like Portland, have a really awesome sound scene, right? There's lots of people making bleeps and bloops and soldering shit together and making horrible and wonderful noises, right? So that's something the 3 cities I've lived in recent times have had in common. However, Portland didn't have something that I find extremely valuable while I was living in those 2 countries, namely an event. So this is selfishly my attempt to get into everybody in Portland's brains and download as much information as humanly possible and then share it to other people. So it was in London, I belonged to a community called Hackoustic, and which came out of London Hackspace. And we did all sorts of interesting things. We did talks just like this, but you know, like they took place over a number of years. This is our first one, but eventually, hopefully, they will bloom into something bigger in a proper actual space with proper AV that I don't have to do myself. That would be nice. But basically, people would come together, and it was like a show and tell, essentially, of works in progress. So it wasn't, here is my project, or here is my thing that I've made and it's perfect. It was a way for people who are hacking on sound to bring their stuff to other people and say, here are the things I'm making, here's what works, here's what doesn't. Just a real open source in nature, but just open sourcing our knowledge rather than our schematics or our code, depending on whether we're bits or atoms. So that's the kind of ethos. I wanted to get people together in a room to talk together, to show off their instruments, but also to provide a place for people to explain their methodology, talk about cool tools that they're using, show off a cool project that they've made, or just really complain about something they hate. You know, that's fine. If you want to spend 15 minutes complaining about MIDI, that's okay by me. Like, as long as it's amusing, you know. So the format will change, I'm sure. I'm a big believer in just starting something and seeing where it goes and then changing it as we go on. You know, and many good ideas have died a death in committee, so let's just get on with it. So today's format, we're having 4 15-minute talks-ish. I've laid a little bit of leeway if they're going to play some music at the end, because that's what we like to hear, right? So 15-minute talks, I'm going to try and have a balance between technical, performance, materials, DIY. Like, I want to have like a range of things. You know, you're not necessarily going to understand, everyone's not going to understand everything that's said, but the point is to be exposed to these different technologies and the different ways of working that are out there. So just think of it like, sometimes if you don't understand it, just think of it as a fire hose of information, and you can just try and like gobble up as much of it as you can, you know. So there's that. So yeah, range of talks, 4 talks. We're going to do, the whiteboard is here. So after the 4 talks, and there will be an open mic, community open mic, there will be 5 minutes and 5 slots. So if there's something that you'd like to show, no slides, no adverts, please. Don't talk to me about your startup unless it's actually cool. Like, no slides, no adverts, you know, no roller banners and polo shirts, that kind of thing. But yeah, 5 slides. If you want to, literally, this is, if you've come across a really cool board, it doesn't have to be your own thing. Like, you could be fangirling about Bella, which is what I always fangirl about. It's brilliant. Yeah. Or, you know, you could have found an interesting new protocol or whatever and show how you work with it. It doesn't have to be like a complete project. It could be a cool tool, whatever. So 5 slots. We'll, after the 4 talks, you can come up and put them. 5 slots. When they're gone, they're gone. So, you know, try not to fight too much. But it would be nice to hear from some of you. So that's the format tonight, and then hopefully there'll be plenty of time afterwards to chat amongst ourselves and show our project and so on. We've got some drinks, although we've still got some drinks left. Okay, brilliant. So I would like to give a massive shout out to my employer, Crowd Supply, for giving us this space for free, and also they bought the drinks. Thanks, employer. For those of you that don't know, we are part of Mauser Electronics, and we are an open hardware crowdfunding company. So we do like Kickstarter, but much more. Like we give you lots more hand-holding. We blah blah blah. Anyway, open source hardware crowdfunding. That's what we do, and we rock. Also, actually, just announced Teardown. So many of you probably already know what Teardown is, but Teardown is Crowd Supply's annual festival of hardware and art and all sorts of weird stuff, and we're doing it in collaboration with SETI. Many of you here are from SETI, so Crowd Supply and SETI are going to smush together this summer for our awesome festival called Teardown, which is June 23rd to 25th, I want to say. It is on the front page of our website, or SETI will, yeah, exactly. Anyway, so that's the big event. Most of you probably already know about Hardware Happy Hour as well. That's another thing I run. Anyway, so that's the kind of the gist of the evening. Also, just in case there's a fire, there is an egress at the back there, but there's also an egress through that door. There's a door behind you, so there's 2 ways out, you know, or it's not very far out of the windows and they do open. So, you know, it's up to you. Hopefully that won't be an issue. So a brief introduction to some of the work that I have done in the past. Well, now I work for Crowd Supply, but previously, before I worked for Crowd Supply, for 10 years, I was, I guess, like a working artist, mostly making instruments and writing about them. I wrote a bunch of books. I made a bunch of products. I've brought some random ones here. This children's book I made called Crafty Kid's Guide to DIY Electronics by McGraw Hill. This is a product I made for Imogen Heap and Pimoroni, which is like the British Adafruit. This is a children's sew-it-yourself, code-it-yourself gestural music glove that does chip tunes. But I've also used it to control Ableton, which is quite fun. This is a hand-embroidered analog synthesizer, which actually is based on the Kraktos, which is an early, like 1960s piece of shit, but it's historic and delightful. This sounds terrible. I never plug it in, but it is cool. It's like hand-embroidered, the whole shebang. That's quite fun to look at. Talking about embroidery, this is a MIDI pad. This is a capacitive touch MIDI pad, and it's really squishy. Look at that. Isn't that great? So I really like making, as you can tell, I like making instruments out of weird things. And here's my like nipple top here. Look, it's capacitive touch. Great. It's got little copper crocodile alligator clip nipple clamps as well. Great little thing. Oh, this is my a disco ball theremin as well. So I make all sorts of weird, frivolous shit. And if you find me on the internet, there's all like I've made tutorials for many of these things. That's kind of how I made my living. Make magazine, Hackaday, blah blah blah, various things. But in terms of like my personal work, I really like to make sculptural pieces. This is one of my creatures. I make a series of creatures. My music is experimental. So I make embedded like physical objects, right? But I like to make experimental objects, but the sound, I like to make it quite classical. I wonder if I've got a picture here. Oh, look at this. Right, here we go. This, and then I'll stop talking. So this is an example of a sound that I like to make. Wait. Yeah. While that's playing, I'm just going to check that the question is So there we go. That is an old, thank you. I'm not going to go into more of my work. I've just got a lot of weird instruments that sound nice. I've done like all sorts of weird things. I'm sure at some point I'll give a proper talk about some of my stuff and go further into some of the technical. So this is made using my favorite single board computer, Beagle board, with a Bella cape on top and a dope cap touch. If anyone uses capacitive touch and you're still using the NPR 121, let me tell you about the Trill. That is a 30-channel I2C cap touch sensor. Like, it's amazing. I love it. That's what this is. So anyway, I'm not going to keep going on. I'm going to proceed to our next guest, who is Eric Schlappy, who many of you will probably already know. And yeah, just enjoy yourself. If there's anything that could have made it more welcoming for you, or if there are things that we can tweak, like this is literally the first iteration, you know, just let us know. Or better yet, do it yourself, right? Better yet, do it yourself. If there's a wobbly chair, you can fix it yourself. You know, if the beer runs out, there's an offie just down the road. So off you go and come back. Like, but that's you know, it's up to you. This is a meetup. This is not a paid event. So, you know, please be kind. Oh, I forgot about this. This is an embroidery microphone I made, and the reason I'm showing you this is because I'm going to be doing a workshop tomorrow at SETI, where I'm going to teach people how to solder and teach them how to make this cheap little. It's a great little microphone. It's literally just a piezo sellotape to a yogurt pot, and then I've just made it like I've suspended it with elastic so that it you know, it amplifies the vibrations. It works really well. It sounds like really lo-fi and cool. Anyway, I'm making that tomorrow at SETI, she says, having prepared not everything, but well. So yes, if you're at SETI tomorrow, I will see you there. So that's it. And without further ado, I will give you to Eric. Would you like me to?
I need a couple minutes.
Yeah, that's fine. All right. So what do you want?
I want the HDMI cable.
Okay, here you go. You can have that. Do you want the USB-C or do you want a headphone jack?
Well, if there's this one, I brought one of my own.
That one's just, that one's not attached to anything now.
Oh, I will
Okay.
use this then.
So there's the HDMI.
Perfect.
And then for the sound, we've got either
I
this
don't
or
need
this.
sound.
You don't need sound? Even better. All right, fine. All right. Oh, wait, I've got a mic you up as well. Everyone's still listening to me. What channel was that on? That's that. Turn that right down. Okay. All right. Can you put that in your pocket?
Sure.
Or whatever, and then we go.
Nice.
Yeah. You get them. So hopefully everyone can hear. All right, good.
Real quick.
Great.
Just tell me if it's too terrible.
You look great.
How terrible is that? Scale of 1 to 10.
Medium, 6.
6.
That's a 5. That's solid.
Sorry, man.
No, this is great. Hello. I'm actually, let me set a timer. But
Very professional of you.
if I don't send a timer, I will talk for 5 minutes and think I talked for an hour.
I'm the opposite, unfortunately. Yeah. I know I am. It's my heritage to be chatty that way.
Right. So yeah, I'm Eric Schlappy. I have a Eurorack synthesizer company called Schlappy Engineering. I'm going to assume you guys know what Eurorack synthesizers are. I released this module last year, late last year, the 3-body. And I'd like to talk about the prototyping process, I guess, for it. It's an FPGA-based digital oscillator. It's a triple digital oscillator with an analog interface. 2 PCBs. One of them's a brain with a Lattice ECP5 FPGA on it. The other one's a control board. I picked the FPGA for some reasons that make more sense than others, but the goal was to have lots of ins, lots of outs. I also generally think digital sound synthesizers sound pretty bad. But as an engineer, I can't leave it there. You have to try and pick that apart. You can't just be an analog snob in 2023. It's like not okay. I mean, you can, but you have to do it with reasons. So the hypothesis here mostly had to do with what I like in synthesizers is audio rate modulation, and that maybe the audio rate modulation in digital synthesizers was because they had a relatively low sample rate. That's kind of a whole different talk because there's a difference between like the internal sample rate, the input sample rate, and the external sample rate. But this does use a 12.5 megahertz internal sample rate so that I can kind of do really simple sound synthesis and not have it alias. There's lots of tricks you can do to lower the sample rate and avoid aliasing. Not going to get into that on this one. Oh yeah, so probably the best reason I picked the FPGA on this is I wanted a FPGA simple project, which this was not, but that was one of the reasons. Also, with the FPGA, I can do tons of parallel ins and outputs. Like, as you can see, there's really a lot of inputs and outputs on this, which is not normal for digital oscillators for reasons involving well, with the FPGA, you can do as many things at the same time as you have space for, as opposed to time. I'm going to leave that one for later too, because what I really wanted to talk about today is what I used to build it. I used the open source toolchain because I think the vendor tools are awful, and I tried to learn FPGA design before, and really, like 120 gig download for the Xilinx software was just, I did not have fun with that. So when I heard from some people in this room that there was an open source toolchain for FPGAs available now, I tried it out. That's the Yosis. I actually started with the Icebreaker dev board, which I believe you can buy from these fine people. So this was fall 2019. I used a lot of different resources, but I think one of the better physical resources I picked was this teeny tiny book called Verilog by Example. Is pretty good. Is this better?
Which FPGA did you use?
So for those that are not familiar with it, the Icebreaker has a Lattice Ice 40 on it, the UP5K to be specific. Yeah, so the open source toolchain was actually really rough to deal with in 2019. You had to compile the toolchain every time you wanted to update it, and there were lots of things that kind of made it not work and weren't very well explained, like setting up a PLL. But actually, most of these things have been fixed for a couple years now, and I would totally recommend it for people who wanted to get into learning how to use an FPGA. So yeah, this is the first, still first iterations, mostly off the breadboard. I made custom boards for the AKM I2S audio converters. If you're not familiar with them, they're these really nice, really cheap audio converters. They're standard in the industry. They actually were totally unsuitable for this project, though. Yeah, maybe I'll get back to that again in a second. So the first revision of this, since the design of the synthesizer is like a triple phase and frequency modulation toolkit with indexes, which are VCAs over the modulation. And for some reason, in the first revision of this, I had an idea that it was more of a hybrid synthesizer. So I did analog VCAs for the indexes. I did 2 4-layer boards. The second one isn't showed here, but they were pretty huge. And yeah, I got everything kind of to work, except the UP5K has only 8 16 by 16 multipliers, which I really tied myself in circles trying to do an audio design with only being able to multiply anything 8 times. And it theoretically has a fabric speed in the hundreds of megahertz, but practically I found with the ICE40 chips, about 25 megahertz is what you're going to get. If you have a really, really slick, slimmed down design that does one specific thing, you can certainly, like people are doing video with pixel clocks of 75 megahertz on them, but you can't really count on that. 25 megahertz is about what you get with ICE40. And yeah, so I spent a whole lot of time optimizing the design to get it to work until, yeah, Brandon Fessler of Mordax over here convinced me I was being insane trying to do that, and that maybe I should just use a bigger chip. Also, I want to note, one of the reasons those ADCs, the AKM ADCs, were not suitable for this project is that these audio ADCs, they're delta sigma converters, and they are really great for AC coupled signals. They really don't know what DC is. And if you try and use them for DC coupled signals like volts per octave CV controls, it's possible, but you're going to really do a lot of filtering and get pretty poor performance out of them. So really, if you're doing CV, you want some sort of SAR ADC. Yeah. So I went back to the dev board and put the Lattice Versa dev board in there in place of the ICE40, loaned to me by a friend because my ULX 3S was taking too long to get there. It did show up eventually. And so I rewrote the code to take advantage of the more resources available, the faster FPGA fabric. You can very comfortably get the ECP5 to run with the 50 megahertz master clock. And without too much work, you can certainly get up to 75 or 100 megahertz on it. But even more important for what I was doing was that it has 28 18 by 18 multipliers. So I could really like make this in the dumbest way possible, like which is what I wanted to do. It was supposed to be a learning project, right? It also has tons of block RAM. FPGA's block RAM is just like these little tiny, like all the block RAMs on the ECP5 are 1,000 bits, I think, like a 10-bit equivalent. So they're very small, but I was able to put sine waves in them and also lookup tables for exponential converters. Very useful. Yeah, so Rev 2, single 6-layer board with an ECP5 12K on it. It was a nightmare to debug that so the ICE40 chip is this pretty slick 56-pin, maybe not, but like not huge flat pack. The ECP5 is a 381-pin BGA chip. You can get smaller packages, but they're even harder to use because they have tighter ball spacing. And yeah, then the AKM factory burnt down. And that was another reason the AKM converters were unsuitable for this project, is because I couldn't buy them. So I was never able to get this one to work, and I just totally lost it for a while. It's part of the process. So later on that year, I went totally sideways, and I made this big thing with 40 sliders on it. The official title is "Holy shit, that's a lot of sliders." And I used it to try out a bunch of other ideas, some of which were related to the 3 bodies, some of which were not, just to like have fun for a while. One of the ideas I tried out was using a open source Delta Sigma DAC based on some Verilog cords I found on the internet. And those worked great. You do really have to put in the work on the analog filters for them if you want to achieve the 16-bit resolution with them. But they were great. And then the ULX3S has these like Maxim Industrial 12-bit SPI SAR ADCs, and those are way more suitable for volts per octave CV. 12-bit isn't really enough, but you probably want something like 14-bit for volts per octave. But you can get there by oversampling the crap out of it, because I'm running these at 96 kilohertz. Yeah, so then the current design, revs 3 through 6, I went back to a 2-board layout. I've decided that if you have any giant BGAs, they should be on their own board. And then you can rev the other board all you want to do. So that has the ECP5, flash, FTDI USB, and an SD-RAM on it that isn't used in the 3-body. It's all logic, no memory. And the control board with the ADCs and DACs, voltage regulators, etc. So the full hardware capabilities is 24 channels of ADC running at 12 bits, 96 kilohertz. A lot of that is oversampled to get more resolution. 4 logic inputs, 11 channels of DAC running at 16-bit, 96 kilohertz. 96 dB noise floor is better than most things in the synthesizer world, surprisingly enough. Yeah. So I'm just about at time here, but the difficulties I ran into and lessons learned, I spent a lot of time trying to figure out a soft core to run on the FPGA to use in calibration routines and talk to my SPI memory. There's lots of open source soft cores out there, but they mostly are like, I don't know, people with something to prove trying to run Linux on everything. They are not useful for this application, really. I have mini chips on my shoulder. Anyway, there are some useful ones, and I will circle back to that at some point. But I did have to finish the synthesizer, so I wrote the calibration routine all in Logic. And WinBond actually has an excellent they have a Verilog file of their flash chips, so you can simulate the whole thing. Multiplexed ADCs require faster op amps than you think you're going to need to drive them because of the internal capacitor. There's this really great series on the Analog Devices website of driving SAR ADCs. I strongly recommend checking that out if you think you're going to do something like that. Also, one of the reasons I did a digital oscillator is that temperature compensation in analog sucks. It also sucks in digital because it all comes down to buying an expensive voltage reference and making sure you're feeding it what it needs to, but you probably couldn't buy them a year ago. So I did eventually find that one that would work, but you do want to pay attention to because parts per million actually has a correlation to ADC resolution, which was something I learned along the way. Yeah, and finding parts during the IC shortage was absolutely miserable. Project took about 3 years to complete. I released it in October 2022 and sold all that I was able to find FPGAs for. I've got a second run that I'm building right now. People like it. If we have time, I can make some sounds with it.
Can't tease us like that right here.
Can you share your first slide again?
Oh.
See your name?
Yeah. Is this the right way around? Yeah.
So Schlappy Engineering is my company. My name is Eric Schlappy. Pretty easy to find on the internet. Any other questions before I bleep?
Wait, no, we don't do questions.
No questions.
Okay, on purpose, because you just have to talk to him afterwards. All right. So play your music.
Normally I would blast you with stereo phase modulation,
Yeah.
but we only have one speaker. So some other time I would love to blast you with stereo phase modulation.
They also have to buy a lot of chairs.
Do we have sound? 5 and 6.
Sorry,
We should have, oh, there's some sound.
is that loud enough? Should I turn it up? Can you turn it up on your thing, or should I turn the speaker up?
Thanks.
Our next speaker is Darcy Neal.
I did not.
This one's you, wasn't it? 5 and 6. Here we go. Let's next. Can I just slap that on wherever you want to stick it? It's sticky.
Oh, there you go.
Put that in your pocket. I never have pockets, so I got the sticky one.
Heck yeah.
I'm just staring in his face.
Yeah, you did great.
Sounds good.
Sick bleeps.
Do I need
Sick
to-
opinions. What do you need?
Do I need to, if there's some audio that's going to come out of my computer at one
Here we
point,
go.
I don't know what just
Yes,
happened
are you
to it.
listening?
Oh, it's
Audio. Here it is. Yes, well done. Do you want the USB-C or do you want this?
I think I just want to just do this. Oh my. There you go.
Give me it back. I've got to connect. Someone's put that
Smart.
There you go.
There we go. That was an awesome talk, by the way.
Oh, thank you.
Yeah. I don't know if that will reach.
Yeah, sorry, is that?
It's just like,
Is that?
here, that's good, that's good. I don't want to block the screen too much. If it's
Yeah.
just enough.
Yeah,
There we
we
go.
need to get some different cables for the next time.
Yeah.
Like it's all like stretched.
And then this
And
goes
that
into,
Yeah, that goes direct. There you go.
oh, wow. That changed. Oh, I need to do like a,
Oh, wait, hang on, it just came out again. This is super annoying sometimes. If you just like, you can see it behind you.
wow, it like changed everything. Hold on. Let me
It's that
do,
HDMI nonsense. I can see it.
what
You
is
might
the,
have better look looking back to the
oh
like,
my God. Wait, it's display. Right. Look at how tiny it made it on my screen.
if you press slideshow, it actually makes it.
No, but it's mirroring my image and I need for it to be 2.
Okay.
Like, what the fuck is,
Display settings here, maybe, or you can drag them. Here we are. So here's uses the main display. Stop mirroring. Right.
did that work?
It looks like it. This is your background, right? So you should be able to just drag it in.
Yeah. There we go. Oh my God, this is hard. I'm gonna do it like that. Somewhere. Ah, it's so hard. Do full screen. Mouse. Okay, does that work? I wonder, just like in front of that. Can't really go too much further than that. That's fine. Let's have to hide. Helen, is this on?
Oh, yes, on.
Oh,
It's
okay.
on.
Okay. Sorry. Oh, great. Noted.
But it's not going to come out of the. Oh, sorry, I forgot to tell you. It's not coming out of the amp, so it's only recording to the stream. So you just have to use your voice.
Perfect. Perfect.
Shall I ding?
Sure. Give me a ding. All right. Hey, everybody. My name is Darcy Neal, and I work with hardware electronics to create custom music interfaces using tactile and expressive designs. And I just got back from an artist residency where my focus was to continue developing an ongoing idea that I've had that is centered around creating e-textile effects controllers. So I'm going to talk about my process with that and what I've been exploring. Okay. Yes. You're good. Okay. So before I talk about the thing that I made, I want to get into like the reasons why I decided to make the thing that I've been working on. And a part of it is that I used to go on tour a lot playing music, played in bands a bunch and all that good stuff. I really loved it, but there was a couple of details about it that I really wanted to improve upon with my rig. One of them was portability. Touring involves lugging around a lot of heavy music gear, going from venue to venue. Then there's also the issue with size constraints. Depending on your travel setup, there's usually size constraints to consider for the amount of gear that you can bring with you. Another thing that I ran into was just the weight of the physical gear. It can add up pretty quickly whenever you're using standard commercial products. And especially if you're doing any portion of your traveling on foot or using public transit or flying by plane, this could quickly become an issue. I was also running into the situation with safety concerns. I don't really have to worry about the risk of my gear being stolen from my touring rig or at the venues or wherever I'm sleeping that night. Because when you're touring, you're in unfamiliar spaces all the time. And so safety levels can be questionable sometimes, especially as a DIY artist and musician. And also aesthetics. I like the idea of a performance rig being highly customized and visually stunning in order to match the aesthetics of the performance itself. And so with all of these considerations in mind, I've been slowly transitioning my rig over to being controlled by a DAW, which is a digital audio workstation, as much as possible, which is excellent for portability, but it's honestly usually pretty boring for the audience, especially when you're just staring at a laptop the whole time, in my opinion. So any chance to be able to step away from the computer and perform on an interface in front of the audience is going to be a plus for me. So with these interests in mind that I just listed out, I've been working to create a series of e-textile effects controllers. The goal of the e-textile effects series is to create an elegant, lightweight, and easily portable music controller that is aesthetically pleasing, tactile, and versatile. I wanted to use the patterns of different textiles to help represent the function of the object and to add to the visual element of the performance. You can see some of the current examples of this in the prototypes that I've created so far that use the suggestions of the e-textile patterns in order to determine the input shapes on the material. These controllers are also created to be as thin and as lightweight as possible, so it can be easily stored in a backpack alongside a laptop, which makes traveling in them super convenient. And I have the same one here so you can see the end result. It just slides, it just fits anywhere, it's great. Should play a little bit of sound. Oh, and we don't hear the sound coming out of this.
Someone turn it down.
Maybe.
Oh yeah. Which one are you? No, that's not the right one. Again?
It's fine. This is triggering sound. It's fine. It's fine. This is triggering sounds that are coming out of Ableton, and I will have the display set up after this if anybody wants to come and play with it. It sounds really cool, but it's Ableton. You can make it sound like whatever you want. There we go. Cool. So I wanted to talk about.
Wait, sorry, turn the...
It's fine. It's fine. It's totally fine. We're over it. It's all good. So I wanted to talk about how the e-textile boards are made and the materials that I've used. And so through the use of flexible, conductive, and non-conductive fabrics and adhesives, I can simulate the layers of a PCB. Once the design is refined and is ready for prototyping, and depending on the size of the layout and the conductiveness of the material, I can either use wires to connect to the sensor board or the touch points, or I can use a vinyl cutter or a laser engraver to cut out the traces for the e-textile circuit board. So it's kind of like a single layer PCB. I use various sensors for controlling inputs and a microcontroller for processing and sending the output signals to my software of choice. There are important design considerations to make regarding what parts of the board can be flexed, what needs to remain stationary, the traces that the layout it's using, and how the materials are layered together, and so many more details. But with all of these techniques, I'm able to create an interface controller that is incredibly thin, fairly flexible, and lightweight. Another important element of the design is the types of inputs that I'm working with. So I'd like to take some time to talk about the sensors that I've been using, as they've been super helpful for creating these multi-input interfaces. My sensor of choice has been the MPR121 capacitive sensing breakout board. The Trill is really awesome too, but it's about $19, and these are about $1 a pop. You probably get them cheaper if you're building your own PCB with the MPR121 IC itself. And so for those that don't know, capacitive sensing is a technology based on capacitive coupling that takes the capacitance produced by the human body as the input, which is then used to detect changes in capacitance coming from the human body for signaling that an input has been touched. There's a bunch of reasons as to why I like using these MPR121 boards. First off, like I mentioned, they're cheap and they're super easy to source. The breakout boards cost about $1 or $2, and probably less if you're buying them in bulk. These generic boards will work with the Adafruit library that was written for their own custom PCB version that's like 5 times more expensive. So there's already a well-written library available to use for this cheap breakout board. They auto-calibrate to the environment whenever it is power cycled and in between touches, which helps to significantly reduce accidental triggers. And it supports multiple simultaneous inputs, so it's easy to use it for polyphonic music applications. And they can control up to 48 inputs over I2C, which uses just 2 pins on the microcontroller. It was a challenge to get multiple of them working together, to be honest, as that was not something that was listed in the library examples or the documentation that I could find anywhere. But thanks to a user on the Adafruit forums from like 4 years ago who actually posted their source code for the solution, I was able to figure out how to use the multiple sensor boards chained together on the same I2C connection. So thanks, dude. We love it. We love it when people actually take the time to post the solutions to their forum questions. So thank you for documenting the correct solution. And so my favorite thing about capacitive sensing is specifically that there are no moving mechanical parts to it, which makes it excellent for public installations. And this is an example of a setup that I made recently that used these same breakout boards. This project was created to be displayed at SETI for the Portland Winter Lights Festival that happened this year. It's about a month ago. The graphics that it's controlling was created by Stefan Biskup III using Unreal Engine, who is over here, who would probably love to talk to you about those parts. And there is no audio to this one, so this is fine. There's no audio to this. No, but so you could see the controller and the multiple inputs. We had LEDs on there too. And this is sending MIDI signals to Unreal Engine. So it's triggering all of this in real time. And there's a whole audio portion to it too that's really awesome as well. But that's a whole other can of worms. So back to the e-textile effects. I want to talk about some of the design challenges that lay ahead for me, because I'd love to bring this up in front of this brilliant audience, because I think that y'all might have some ideas that could potentially help me. So after all of this, I'd love to talk about it. One of the issues is that I want to be able to have inputs that send out a variable signal. The capacitive sensors are currently being just used as on and off switches, and I want to be able to send a variable signal to emulate the turning of a potentiometer in a very low profile way. There's also questions about what was the best microcontroller for the project, and what I've used so far, and which ones I'm now exploring. And now there's a train. Yeah. Just let the engines pass for a minute. Okay. And I'd also love to be able to talk about ways to customize the output so that it could be used for various users so that it's accessible as possible. But I'm not going to have time to get into this because that's a whole discussion on its own, but I'm totally down to talk about it afterwards. There's a whole bunch of slides that I'm not going to be showing focused specifically on that. So now that we know what capacitive sensing is, and we know that it could be a great way to create low profile input buttons with no moving parts, but like I mentioned, it's really just for on and off control. So how do you create a flat and variable input sensor to mimic a potentiometer? I know that capacitive sensors can measure some distance proximity, and with the right code, you can also use it to detect pressure. But for this application, relying on a greater proximity would have changed the design layout to be much larger with more space between the inputs in order to avoid crosstalk, and it would have been more difficult to control. It wouldn't have given me the results that I was looking for. If it was behaving like a theremin, like if I was making a theremin that only had two inputs that were far apart, that would be totally different, but this application requires a different solution. Another solution for creating a variable input is using resistive input on electrodes. This is a fun and super simple way of doing this, but if it's relying directly on human touch, it tends to be less predictable, as the conductivity of the skin will tend to vary depending on how dry the user's hands are. So it's super lo-fi and cool, but not accurate enough for what I'm trying to do. One weird option that I've heard about is where you can use a zipper with resistive conductive strips on either side of it and a metal zipper that bridges the two traces. It's an interesting application. It's very low cost, but it will produce a very messy signal as the breaks in the conductivity is fairly inevitable with this design. So we're not doing that either. Another idea is to use repeating messages that can ramp up or ramp down the value of the output. And this technically works, but the speed of the change is going to be fixed so that it would be hard to quickly jump up and down to a different value. So it's less expressive. A solid option that I found is to use soft pot strips with some fancy code behind it so that its last touch position would dictate the value that is being output. With the addition of an LED strip or some other kind of indicator along with it, you could have feedback as to what that current position is. I'm concerned about this idea just because it's going to increase the cost of the BOM, the bill of materials. for this build. So I'm not totally sold on this idea yet, but it is probably going to be one of the cleanest designs for it. But it's going to cost a lot. These things are not, they're expensive. Another idea that I've been looking into is using different gesture recognition boards for detecting swipes and other directional movement, like the Trill Flex or some other kind of a breakout board. I'm going to wait. Pause. There we go. So this is totally intriguing, and there's a lot of really cool gesture recognition boards out there that can detect swipe and stuff like that. But that's a whole other rabbit hole of research that I'm just starting to get into. So if you have any ideas about other ways to easily generate a low profile variable input for this design, let's talk after this discussion. Oh, that was already on it, whatever. Okay, so I want to get into the next phase of this goal, which involves choosing the right microcontroller for this project. So far, for all of the builds that I've done, I've been using the Teensy microcontrollers for it, which are great because they have native USB MIDI built into it, which means that it's automatically recognized as a MIDI device whenever it is plugged into a computer without the need for any plugins or third-party software. There's tons of helpful libraries for it. It's really well supported by the Arduino community. So it's an awesome board, but I really want to make this work as a wireless instrument. So in that exploration, I have stumbled upon the Seed Xiao, however you pronounce that, controllers, particularly their NRF 52840 microcontroller board, as it's well optimized for wearable applications and other unconventional applications. They're cheap, they're tiny, they're Arduino, MicroPython, and CircuitPython compatible with Bluetooth low energy and NFC capabilities. And it also has integrated battery management, which is really nice for a wireless application. I'm just barely scratching the surface of this new series of microcontrollers, and I'm excited to get into it deeper. So feel free to geek out with me about this later if you would like. And with that, that is my talk. Thank you for listening, and I hope this inspires you to go make awesome things.
We have one final speaker. Thank you, Darcy.
Yeah, you're welcome.
I would like to say that I did bring a bunch of different, if you've not played or had a go with any kind of e-textiles before, they have come on so much more. I brought a whole bunch of materials.
Thank you.
Good. Adapting some of the Trill stuff because it's open source.
Yeah, but they're $19 each.
Yeah, but the Cypress piece opposite, you can make your own PCBs. All the schematic stuff, all the board design parts of it are open source.
Oh, fuck.
Uh-huh.
I didn't realize that part.
One just put me on it last week, and I'm just
How
I
much?
borrowed one from Sadie. And it's like, you know the sound machines, the Eurorack ones?
No.
Okay.
So I literally just got a new phone. Oh, fuck yeah. Oh my God, that looks so good. Thank you. Yeah, there's a ton of them. So good. Thank you. So good.
And I've got some stuff that I did for the softball too. Just I have something in the trunk that I'm gonna go get after this.
Hell yeah.
I have a 1 meter long potentiometer.
Of course you do.
Bought it from an auction. It's a 1960s electrical engineering teaching device.
Yeah, starting to understand what you've got, like, that's it.
It was fucking dull.
Mhm.
And when I went there, I take 2 of them.
You have to take 2 of them.
It's fine.
Don't take them all.
Take 2, yes.
No, I've run into that. I have these crazy giant boards pulled off of like huge industry test machines that I got at the garage sale, and they were like, you can have them, but you got to take them all.
Yep.
Oh shit, I'm still wearing the microphone. Hold on. I gotta take this thing off.
Yeah, it's just inspiring to get back up.
Having like a CD recorder. That'd be sick. Yeah, that's the thing. Those fucking things are like $20 a pop, dude. Like even on like buying bulk, they're expensive as shit. They break. Because it's like a little tiny loader. It's a little belt. It's a little belt.
Here's.
You know, it's
You put that in your pocket,
Alrighty.
and then I'm going to stick this on you.
Cool.
There you go. Hopefully they should be able to speak. This is where the camera is.
Mm-hmm.
All right.
Alrighty. Hello. Hello. I'm excited to be here. I'm Timmy. GNU Linux loves all. Together, we can liberate technology. So now, I guess this isn't too exciting, but I'll show you how it is. So I'm just going to talk about a QWERTY and some mice. So this here. So this is a Big Sky Strymon pedal, and I've been using this for a number of years. And it has a MIDI jack on it. And so there were some things like, look at all these knobs here. And I wanted to be able to control them with some manner, like, or customize like what you want to do with this. And so this kind of set me on this path. So here is the manual. And what's really cool about pedals like these is then they just like give you the MIDI, like all the MIDI numbers and what it does basically. So you can just like with a different device, like set that however you want. So then, let's see here. All right, so what I did was I took this mouse, and so one does this, and it sends the MIDI over to here. So that's doing the decay time, and then I have it turned pink because when it goes all the way up, then it sends a sustained signal, and then this is the mix. So I've been I spend a lot of time with different instruments because I love playing all kinds of instruments and I can't stick with one. So I was very inspired by keyboard and polyphony on violin. So yeah. So here's a little look at my, basically I just take the mouse and I use MINI.MU, which is something that only works on, oopsies.
Your microphone.
Oh, okay.
Screen down a moment. I can get you a new sticker if it doesn't work. Yeah. That was really good. Keep going.
Cool. So what's really cool about MINI.MU is that it can grab the mice. So I'm not like typing random stuff and clicking on random stuff. Who knows as I'm playing, which is really nice. So yeah, check this out. So it turns, so then like what I do is right here is both of these mice show up as different names. And so then I basically just, and look, my trackpad is still moving. So that's one thing that's cool is you can just grab whatever device you have. And I'm still typing on my keyboard, but not with that keyboard. So yeah. All right, so the next thing is then I'll go with this QWERTY here. So I have guitars running, which I'm using for distortion. And then I also have Super Looper running for delay, and I'm controlling those. So I have delay and distortion on my pedal board over here. I'm not using those because I want to be able to just like say whatever you have in mind, code it up, and then like you hit it with a button and then it does all you want. So one thing to note about QWERTYs, of course, is that they're not fully polyphonic. So so I made this little thing to see like how, like I'm hitting E right now, but it's not going. So that's why, of course, I took off the keys of this keyboard so that and And then here it says, I love GNU too. Yeah. And that keyboard, I think I got at Goodwill for $5. So that's another thing that's cool about these is, you know, there's a bunch of way expensive MIDI devices out there, and I'm not too, I mean, you can find this stuff in a closet somewhere. Your friend will have an extra. So that's one thing I think is cool. So, so let's see here. I need both hands. All right, so here is my QWERTY code, and I define things in a different file. My goal is to just basically make it so that you can easily, so make a button, for instance. So what this does is it changes Super Looper, the feedback. It goes between 60 and 85. And then this Guitarix, it connects to Guitarix. So you can see I'm like doing these jack messages where I'm like unplugging and plugging stuff in. And then this down here is what sets it up. So then like I run this file and then it brings up Guitarix and Super Looper and then like some equalizers. So then it's all ready to go. So, oh, and I forgot to say this thing. I found out one thing that's real cool is that it's pretty easy to make a MIDI device. So I've been doing it ever since, basically. So this is just, this is a Wemos D1 Mini. And here's some MIDI things. And I lost this board and I just have it on like a breadboard over here. So what I did was I wrote, it's a simple like takes in serial, and then I have a little thing that converts the serial to USB. And ever since I found out how easy it was to make your own MIDI thing, I've never bought a USB MIDI interface since. Alrighty, so last I'll play for you a bit. I do use this stuff for performance. That's what's really, really cool about it. I was just on a tour with a band, Mind Parade, and I used the mouse for that. And so now I'll play a little bit of one of my tunes, Ode to GNU General Public License, a protector. A protector of free technology. And I bring these guys along for performances too. So how much time do I have?
Just play violin.
All right.
Play violin and we'll all go have a drink.
So 5 or 10 minutes.
We all want to like.
All right.
10 minutes.
Yeah.
We all
Yeah.
want to, just
Yeah.
yes.
Alrighty.
Yeah.
Just play, man. Whatever
Cool.
comes, whatever comes. Oh, that was dope. Thank you so much for sharing that with us. All right, we're going to take a short break now. Go and, use the bathrooms, have a cigarette or whatever you like to say. Drink whatever's left of the beer. And we have now is the time. If you have there's five 5-minute slots after this break. If anybody has anything burning to share in a couple of years, have thought some interesting things to share, please come along. I'm not adjudicating it. It's first come first served. So like get ready. So the open mic starts. What time is it now? We've got like
6 after 9.
it's 6 after 9. So at 9:30, let's do the open mics. Let's do that. Yeah. 9 open mics.
How many modules? Actually, 4? Is that 2 of your oscillators and then
It's the 2-body and 2 of my
Oh, okay. That's so simple. You had so many
The cheapest fucking microphone. That was so good.
I should give you the mic.
2-body rig. The 2-body.
Hello, people who are watching the stream. We are gonna take a break. I don't know whether to stop the stream or not. Pipe up in the stream. Do you wanna come back in half an hour to hear the to hear the open mics, or shall I just end it? I don't know. Let me know what you want. And I will do such a thing. Or I guess I could show you around some of the projects here. There's some interesting things, but I can't do it with a normal camera. I've got to do it with my phone. I'd have to dial it in. But anyway, pipe up in the comments if you'd like to stay or whether I should. If you want to listen to the ones afterwards, I can keep it going. But there's going to be a break for 25 minutes. That's all. I'm gonna put it. I think I'm gonna put the microphone on one of the tables so they can eavesdrop. They can eavesdrop to the sounds while we're setting up for the next one. All right, live streamers, I'm putting you on a table with lots of weird instruments. Maybe they'll make some noises. This is mine. Those are the streamers. I'm gonna listen to your conversation. What's in the background?
So you are going to have some delay.
Are these yours?
Yeah.
I should have guessed. So what's your tuning system?
So they're similar to there's something called kite guitar, which is invented by a local guy that normal kite guitars in 41 Edo. And the trick for doing it is that if you omit half the frets and then only have the notes each note's available on every other string, then it works surprisingly well. And so this is basically the same layout as kite guitar, except I decided to, instead of having it in 41 Edo, I have it in just intonation. So I moved where the actual frets are, but you play it the same way as you play a kite guitar. And there's some slight differences between this one and that one.
So, do you perform works of Harry Partch on there?
No, I don't. I'm actually not sure where I'd even find sheet music for this stuff.
I don't know. He's just who I associate with just intonation.
Yeah. I mean, mostly I'll play like normal music. But,
Wow. Can I check that out?
yeah. I need to glue the back on, but
I'm just taking your word for it that it's tuned.
it might not be. I mean, it might have. I might have bumped a few frets.
So what are the holes for the fretboard?
That is my movable capo system.
Okay.
So I've only got one on there. But
What is this?
Oh, so much. I mean, look at it.
Oh, someone brought some little bits. Nice.
yeah.
So these yours?
no,
Oh, nice. I love these. I remember when these came out.
yeah, I've never actually used them, but they
They're
certainly
cool.
look fun.
Who made this?
Oh, that's mine.
That's a real fucked up guitar, man.
It at least plays in tune.
Yeah, it
There's
does.
some definition of tune,
Which
yeah?
tune? Which tune?
I mean, you can play normal 12-ish music. On it.
It's fun. I've never seen something fastened quite like that before. There's something that's a little bit disturbing about that.
Oh, to have
The
tuners on
headstock
that
at the
thing.
bottom. Yeah.
It's good for balance.
Yeah, I
It's
see it.
kind of-
I get it. Like,
We've had a few guitars and
It's,
guitars things we've done.
it's
It's like
It's
some
a visual-
monster movie where like monster has an arm coming out of its head, and you're like, what? And also, because like difficult to tune, you have like the bridge. Like,
Yeah,
tension is being pulled.
Yeah, it goes over 2 friction points, so in theory it should make tuning worse, but
Right.
it hasn't, in practice, it hasn't really been a problem.
Okay, so it's kind of glides along.
Yeah, I should, if I make another one, I'd probably offset the headstock vertically a little bit. So that break angle is not so bad. This break angle could be steeper. I didn't want to put too much strain on the top.
You have like a microtonal scale happening with
Yeah. It's so what is it? It's close to. It's complicated.
like Middle Eastern leaning or something like that.
This
or-
is no, it's close to regular like 5-limit JI, but this one I tempered it slightly to make the 7-limit stuff a little better, and the 5-limit stuff is slightly off, but it's only off by like 3 cents, so it's not noticeably off. And then this one's pure 5-limit.
Oh, that's cool.
When you have the ratios for the scale you want to make, how do you calculate and figure out? Because I imagine like the computer spits out a number for where the fret has to be, and that's not exactly right.
Yeah, I've got a computer program that I tell it what scale I want. Like you just tell it, these are the notes I want, and then these are the tunings of the strings, and then it spits out the appropriate fingerboard for it.
Have you seen the little adjustable kind of things people have made where they like can actually slide the frets
Oh
themselves?
yeah, there's a guy, Tolga Khan, yeah.
We were just
It looks
talking about
complicated.
Yeah.
It's a cool
Well,
concept.
I mean, it is and it isn't. It's a bit of a learning curve, but the funny thing is that this is basically played exactly the same way as a kite guitar. There's this thing called kite guitar. There's a local group here that makes kite guitars. There's a guy named Kite who invented the system, and kite guitars use normal kite guitars use straight across frets, but they're fretted to like 20.5 equal temperament, and the trick is that you can play in 41 tone equal temperament, but if you omit half the frets, then only half the notes are available on each string, but it gives you a lot more room. Like a trying to do a full 41 equal tempered fretting, it's just too many frets too close together to be easily playable. And it turns out that if you're clever about how you remove, like which frets you remove and how you tune the strings, you still get all the notes that you want close together for playing normal, like regular Western music. But you also have a bunch of new notes that you don't normally get.
You can mix like microtonal with like normal equal temperaments. You can mix microtones with equal temperament. That kind of thing.
Yeah. I mean, you can. So equal temperament, the 12-tone equal temperament is an approximation of another system called just intonation, and it's pretty close for some things, and it's not so close for other things. Like major thirds in equal temperament are off by about 14 cents. They're just not. They could sound better than they do, and we just put up with it. It's not that like if you heard the just intonated major third, you'd be like, oh, that's a weird sound. You'd be like, oh, that just sounds good. That sounds like it's supposed to sound.
Depending on how it relates to other notes or
whatever. Yeah, the tricky part is that if you try to do just intonation everywhere, then you get this problem. You get problems of like, well, okay, now you suddenly need more notes that you didn't have. Like instead of 12 notes per octave, you need like 20 or 30 or 40, and it kind of explodes really quickly. So this way is a good way of getting. So the way like half the notes are omitted on each string, it allows you to have enough room to move around without having a ridiculously crowded fingerboard.
And on yours, it's just like turned into a fretless at the bottom there, and you kind of.
Yeah, well, I was lazy. I didn't want it. It's like I don't play up there anyway, so. I mean, on an acoustic guitar, like the body would be there, and so you normally don't even have access to that. I think that's two octaves.
Trying to do like a solo or something.
So yeah, that would be like the 24th fret on a regular guitar. And so on an electric, that would be like a 24 fret electric would be a pretty full fingerboard.
So the idea was like make like a headless, but with.
Well, this is just a. Well, I got into building cigar box guitars a while back, and this is just a trick for making them easier to make. And usually I don't laser cut. Like I got a laser cutter, so now I'm like, okay, how do I use laser cutting to make better cigar box guitars? But a lot of my guitars.
Oh, it's all jointed. I didn't just notice that.
Yeah, a lot of my old guitars, this would just literally be a cigar box, and the neck would just, this piece of wood would just stick out the end, and I cut a groove in it and drill holes sideways and attach the tuners. Instead of having like 8 in a row, I'd have like 5. Instead of having like 4 and 4, like an 8 tuner setup, I'd have like a 5 tuner setup, and they're just all in line instead of side by side, and that works pretty well. The kite guitar setup, you're like, yeah, I need way more strings, so 8's a really good number. Because you only have half the notes on each string, you're like
kind of like bass and guitar at the same time, a little bit.
Yeah. Well, this is about the same range between the low. It's tuned in major thirds, so it's a closer spacing than if it was tuned in fourths, mostly fourths. So if you want to have the same range this way, or maybe a little bit more, then you really need 7 or 8 strings.
I've seen this thing with like people do with the holes, and when they do microtonal, what is that about?
This is my adjustable capo system.
Oh,
So it's kind of weird looking. I think I should have made the holes a little bit smaller. This fits a 3mm machine screw pretty well.
Depending
But I
on how
could've-
you tune it, you
I
may
could
want
have
to
used
change where
smaller
the little
screws.
hand is or whatever.
Yeah, you're like, hey, I want a capo on that fret, and so I put that there. If I wanted it somewhere else, I'd put it somewhere else. And it's just kind of the nature of the tuning is that you often want to capo things, and
Yeah, so in case the fits on.
you really
capo
want
parts.
to individually capo things. This is a bit of a trick where I'm capoing one side but not the other. It's a lot easier to just have one screw that holds down two adjacent.
Oh, so that's
screws.
basically what this is.
Yeah, it's holding this one down. This one is supposed to vibrate freely, but it's just a little hair too close, so it rubs. So that needs a little bit of tuning. But I also have these, which are they're simple setup. And then this is kind of a similar idea, but it's a 5-string. I put zither pins on it. These are cheap and easy to install.
It's like from banjo or something like that. What uses those?
Oh, you'd see these on a auto harp.
Oh yeah, sitar
A
or something
zither.
like that.
There's a bunch of instruments that
Like the string, the
what is it? Hammered dulcimer.
yeah, those kind of stuff.
Yeah. So these are like 10 cents each or something, or 25 cents or something.
Gotta have a certain kind of like some kind of tool or something that fits on that. Or?
Yeah. Need one of these.
Oh, okay.
Just goes over it.
That's easy.
It's a little bit like piano tuning, and it's fiddly.
It saves some space too. I mean,
Yeah, it saves space.
The tuner sticking out a little.
It's super stable. Like I don't have to worry about I'm going to bump the headstock and knock it out of tune.
Why people like the headless guitars, right? They can just like sit down and make music, and it's not like a big thing sticking out.
Well, also locking nuts do the same thing.
Is this the newest implementation?
Sorta. So I made this a long time ago. This is like probably 3 or 4 years old. But I've been working on the PCB that goes inside it.
Oh, okay, right.
So
that's the new development.
that's what I've been doing new, and I would have brought it, except the PCB is in the mail. It's like currently coming from.
You play one of these things.
And then, is that one set up?
Yeah, that one's set up. Yeah. So
Yeah.
hopefully it works.
It's just.
You said you tuned that in major thirds.
Yeah.
Do you have commas every 4 strings that you have to deal with?
Well, that's sort of why the nuts offset. I mean, this one's a little bit more. It's a little bit more obvious. Well, actually. Like these are some of the weird commas that show up. This one's also they're almost the same tuning. Conceptually, they're basically the same, except that this one's tempered slightly differently. So if you look at this, the space between these 2 frets is a little bit wider than it is on these, and that's for complicated reasons. I wanted the 7 limit stuff I wanted to be able to do both 5 limit and 7 limit stuff, and the 7 limit stuff on this one is fairly far off. So I was like, okay, if I can make the 7 limit stuff a little bit better and make the 5 limit stuff just slightly worse, it's a good trade-off. And so that's what I did.
How did you figure out how much to adjust?
What did I do? I have some software that I wrote that does most of the calculations. What I was looking at was the difference between 25, 16, and 74, or something like that.
And you applied that to all of them equally? Or that approximation?
So I basically, what I did is I replaced all the major. So when my program calculates where the fingerboard layout is supposed to go, wherever it would use the major third, which I'd normally define to be 5 to 4, I defined it to be something about 3 cents wider or narrower. I can't remember. So it's not 5/4 anymore. It's some like horrendously ugly fraction. But the point was that it made, it makes the 25, 16 interval a little bit wider. But if I'm using that as and 7/4 is the same thing, then it's kind of splitting the difference between those two.
Yeah.
Grid matrix something.
That's really cool.
Yeah, the nice thing is that, so you're familiar with a lattice or a tonus? Yeah, so the size of the lattice that I'm using with these is, for a guitar, it's absolutely huge. It's like a grid that's 8 units wide and 5 units high. So that's like, you can start at a note and then go up by 7/5, or you could start at a note and go up by 4 major thirds without falling off the edge of the lattice.
Okay.
And usually you can't get away with that on a guitar because it would be way too many frets. But the trick is, well, you omit half the frets, then only half the notes are available on each string, and it just works out really nice.
That's incredible. That's so cool. What's your name?
Jim Snow.
Jim?
Yeah.
Nice to meet you. I'm Luna.
Luna. What is this thing? Oh, that's another guy's project.
Are these your projects?
Yeah, these are my projects.
And they are tuned. They're tuned to specific scales.
So these are tuned. The strings are in major thirds, and the tuning is a just intonation system that is. It's an approximation of another system that's called kite guitar. It's kind of a strange system. It's like I'm approximating a thing that's an approximation of something else. So,
It's just, I mean,
but it turns out
all you had to say is just intonation.
Yeah.
So, where? I'm sorry. No. I just want to know what is your what drives your creation of this specific instrument versus this specific instrument?
Well, this one I made first. This one I made because I wanted something with nylon strings, and I also wanted more strings because 5 isn't really enough for this. I mean, you can. This is a perfectly valid instrument. It's perfectly playable. But there's a lot of stuff that I can't play without more strings, or at least not easily. So this is just a way of getting a bit more, just a little bit more flexibility. But the basic design concepts are similar. Like the tuning is almost the same. They're played exactly the same way.
I'd love to hear them. Is there a purpose behind the holes in the?
Yeah, this is my adjustable capo system.
Oh yeah, what is yours? Yeah,
This is
it's just a MIDI controller.
this
but it
holds
has more
down the
knobs than
spring there.
That's
So
a
the idea is
Are
that
these potentiometers or encoders?
in capo, any of these
There's
strings
an
that
encoder for
didn't
like the
belong
menu. You can
individually, or the easier way to do it is to capo 2 at a time, like capo 2 neighboring strings.
12.
Or you can use,
More fucking
in the
knobs.
cases where you can use
So tell us more about it. What do you use it for?
So for
Is there
years,
a,
I've been frustrated with
contact microphone inside of it, or is it acoustic?
yeah, there's a piezo. This was it K&K Pure Mini Classical guitar. They're really great pickups.
I haven't heard them personally, but
Yeah, they don't. They sound great, and they don't need a preamp.
map the buttons to
So that's like, what else can you ask me? They aren't cheap. I wish they were.
Crowd supply project.
oh yeah.
Although
What's your name?
Yeah.
Jim. I'm John. Nice to meet you. Thank you for making these awesome, beautiful instruments.
yeah, so
I love to hear them.
yeah, so
Real
now
solid,
when I set
man.
this up,
Do you have
like,
music out in the ether?
pick it
No,
up?
no, I'm just kind of a musical hobbyist.
Awesome.
I kind of got into the musical instrument side of things.
Okay, I was wondering.
There's a
yeah.
group that does light guitar that hangs out locally. There's a website, tightguitar.com, and
presets, right? So I've used
we do like every Sunday we have an online meetup. It kind of started with COVID,
so like I might have one preset for like
anyone that's interested in this kind of guitar can hang out.
and then one for
It's K-I-T-T.
Yeah,
I'm not familiar personally with the type of the guitar, but I've all instruments. And specially expanded tunings. Cool.
Right now the formula is without I kind of stuck in coding, so it works.
Yeah.
It's hard to
Take guitar.
But when it's on, the screen shows you when you turn a knob.
What are these? Are these all? These
That's
are
somebody else's thing. Those are for a little bit.
Oh, that's a little bit. Yeah, right.
Basically, it's a modular synthesizer.
Cool. Thanks.
Let's see, did you see the that one?
So cool. I love all of them.
I need a color. It works, but it doesn't have the features.
I mean, you've got all the knobs and all the buttons.
At least almost. You would think that that would be enough. But it turns out it's not nearly enough. You really need like 4 to set out. So the features that I want are presets. Right now it's just one preset. But I want to be able to use these buttons to lock it into the
And you mean changing like down to controlling what channel it is and what kind of message it's sending and stuff?
Yeah, like maybe I want this full swing of this knob to only actually do like 4 steps.
Right.
Yeah, so like type of thing. Yeah, so there's a lot of features I want to add, but I don't know how to do it.
So is this now on a PCB inside? I mean, did you hand breadboard this to begin with? Or?
No, dude.
Okay.
No, this is not my first MIDI controller that I've played. This is definitely the most like coherent one that I've ever made.
Wow.
Yeah, it's just tons of knobs. It just sits there and the screen sits above it. And then there's multiplexers to deal with all the knobs. Well, you got a multiplexer, yes. So Tingy has a lot of I/O, but not this much. Yeah, so circuit-wise, it's pretty simple.
Just repeat.
Yeah, just repeat.
But how did you get there? Did you do the PCB layout?
I did, yeah. So I started thinking maybe I wanted it to be modular, so I did like strips of two channels, and then I had this whole ribbon cable situation.
Yeah, I bet. That was
Yeah. So I was thinking maybe it'd be good to do modular. So my first prototypes were these strips. And so I ended up abandoning that, but it was really good because I did several prototypes testing the distance between the knobs. I got it as tight as I could.
Yeah.
Yeah. Any tighter it'd be hard.
Yeah, it feels pretty good though. It feels like you can grab one successfully.
Tonight I want to do a deeper talk on it next I'm going to sign up for the next one.
Wait, this is on the table. Oop, let me just put my put that on you. Oh, yeah. Put this in your pocket.
It's in my pocket.
Anyway.
Does that help? Does anybody hear me?
Yeah. Well, no, it's not for here. It's for the stream.
Oh, hello, stream.
Yeah. Hello. Yeah, the camera.
You can hear me.
The camera ran out of battery, so hello, stream.
And
Hey to everybody. This is the internet. Okay.
and if I bring this up, will it come up?
Let me just check. No, there's no gain.
I'm all the way up.
No. There's no gain on my thing.
Oh, there it is.
Yeah, like here.
Boom, boom. Oh, and a lot of heavy reverb,
Yeah,
which is cool. Hi. Okay, 4 minutes remaining. So I'm way over here in this corner because I'm connected to the audio system, but this board is quite small, so you'd have to come a lot closer if you want to see it. But I can describe it to you from there. Can we take some of the reverb off? I bet there's an effects knob that just goes down.
I don't think there's. I think it's just.
There it is. That's it. Oh, sorry about that. Hi. So I made a thing. Now this thing in front that's really cool. I didn't make. Some of you probably recognize that this is this wonderful thing called the Pocket Operator, which is one of a series. It's one of a series of really beautiful drum machines made by the people on the stream are also normal.
I mean, meat space people. We're in the meat space now.
These fantastic little handheld drum machines made by Teenage Engineering of Sweden. Maybe you know them, maybe you don't. They've sold a lot of these. They're pretty popular. So I lived in Berlin for a while where the only music is techno, and it's really interesting sometimes, but it's also very rigid in its tempo. It's all very, machine controlled, clock driven music, and people are. I mean, that's an exaggeration, but like there's a lot of clubs where that's the type of thing you can dance to. And I'm a live musician. I play the drums myself, and I like to play in a syncopated fashion. And I got to wondering, how can you play a drum machine in a syncopated fashion? And so I made this board that fits on the back of the Pocket Operator. And it's got an accelerometer in it. And it does beat detection. So if you hold down these two buttons, it'll get when you tap it. And so now you've got this drum machine and you're kind of playing it the way you would play, that's okay, a tambourine or something. So like you could be listening to a song and the song's like kind of fast and you're like getting in sync with it, or you could be listening to some other musicians and getting your drum machine into sync with it. And then like when you can let it go, once you're in sync, there's your tempo. Maybe you get a little bit behind and need to speed up a little bit. You can like make little subtle adjustments to the tempo to keep it on and off, or they can listen to you. But what it's really about is like, if you're an electronic computer musician and you want to play along, jam with some live musicians, which isn't to say that anybody's dead, but like, you know, some acoustic musicians, a guitar player, piano player, drummer, you know, those people are used to like a back and forth listening. Those people all hate to play to a click track or to a drum machine because it's really just unforgiving. Like once you start to drift off of a live drummer's beat, the live drummer, sorry, a little bit, it's the cable, it's a little bit stitchy. The live drummer will adjust because everybody's doing this thing of listening and trying to fix the tempo to where they hear it happening. So it lets the electronic musician use this to kind of try to give back the tempo a little bit in a human way. So you can do this with the drum machine, and it's a great little drum machine that I really like. But also it sends out a MIDI clock, so you can control Ableton, you can control all of your other MIDI-based stuff. It sends it on USB. It'll also send it on the TRS jack, so you can run it to your antique MIDI stuff. So your vintage MIDI stuff. So that's it. That's all it is. And so I did a really great crowdfunded campaign. Got some money off of Crowd Supply. Thank you so much. We're doing the final shakedown of all of the features right now. We're going into manufacturing next month sometime. They're going to be at the backers. You can order them now. They're going to be available real soon. Hopefully we'll make some more of them. That's it. 5 minutes. Thank you.
Unless anyone has anything. Oh, what's the point?
How slow will it go?
Oh, dude, so slow. I mean, it's interesting because the Pocket Operator itself has a tempo knob on it, and it only goes down to 60 BPM. But you can get this thing to be like, and then technically speaking, I think you've got about 40 minutes before you get the second beat in. I mean, okay, how many microseconds fit in a no, that's not even the limit anymore. No. A lot, very, very slow, excruciatingly slow. But the top speed limit is actually currently 300 BPM, which seems like unnecessarily fast. But then I went and read about the world's record for fastest tempo played on a drum, and it's insane. It's this little kid in India, and he played 2,400 BPM for a minute for the Guinness Book. So, like, I don't think he's gonna buy one. But I hope that everybody else will. Thank you.
All right, thank you.
Thank you.
Thanks, Helen.
Likewise. I'm really puzzled now with like, what is the absolute slowest that it could go? Thinking about the firmware.